Hi, my name is Vivian, and my group members are Ryan, Javier, Dalton, and Micah, and we're going to be talking about impulse and momentum. Momentum is a quantity expressing the motion of a body or system equal to the product of the mass of a body and its velocity, and for a system equal to the vector sum of the products of mass and velocity of each particle in the system. Impulse is defined as a force applied over a period of time, which can be seen as the area under a force time graph. The momentum impulse theorem states that the impulse applied to an object will equal to the overall change in its momentum. And then next is the experiment introduction.
All right, so for this experiment, we decided to focus on the concept of impulse momentum by applying it to a common subject most people would be familiar with, that being billiards. The way we integrated impulse momentum into our experiment was by observing the change in momentum the cue ball undergoes as impulse is exerted onto it. So the equipment material we will be integrating into our experiment include one cue ball, one cue, a recording device such as a phone camera, a pool table, a graphing program such as Vernier video analysis. And next up, we have Ryan presenting the formulas and information needed for this experiment.
So what we need to know is the mass of the cue ball, which is 170 grams, the formula for momentum, and then the impulse, which is a change in momentum equaling the change in mass times velocity. And since mass is constant, the impulse can basically be calculated via mass times velocity final minus velocity initial. And then in the next slide, we'll show our demonstration.
So a very simple demonstration, just a cue hitting a cue ball, but using that demonstration, we can pretty accurately get an estimation for the momentum and the impulse. So the momentum for the cue ball after the initial force from the cue is applied can be calculated just by mass times the velocity. Those blue dots on the video or on the picture in the top left show the path that the ball is taking the entire time. And it's important to note the velocity that we used for our data is the average velocity before the ball hit the wall and after the ball hit the wall. So for the initial velocity of the initial momentum of the cue ball, we just do 0.17 kilograms multiplied by the average velocity, and we get a momentum of negative 0.28 kilograms times meters per second. And the momentum of the cue ball after ricocheting off the wall is just going to be the same thing, but with the average velocity after it leaves the wall. And then using those two momentums, we know from the impulse momentum theorem that impulse is just going to be the mass times the change in momentum. And so from that we can, change in velocity. So we know that the impulse of the cue ball is going to be 0.44 kilograms times meters per second. Using that, because the definition of impulse is that it's the force max multiplied by the change in time, we can see from the graphs on the right-hand side that the ball was in contact with the wall for about 0.03 seconds. So using that was our change in time multiplied by the impulse that we had just found, we can find that the maximum force that the ball exerted on the wall was about 14.67 newtons.
So in conclusion, by using the data analysis software, we were able to find the exact velocity of the cue ball with a known mass at every point along the path it took. We can then find the momentum of the ball before and after contact with the pool table wall. Due to the momentum theorem, we can then calculate the impulse of the collision between the wall and the cue ball, and subsequently the force the ball exerts on the wall.